The cosmetic industry has been growing the past century relying on fossil fuels. Many of the conventional ingredients and active compounds designed and used in cosmetics are based from petrochemical oils, such as parabens, silicones, mineral oils, synthetic polymers, and many others. This is inevitably attached to the depletion of limited resources and high contamination and degradation of the environment. Nevertheless, with the rising consumer awareness and the environmental impacts and health risk of petrochemical ingredients, there is a need to transition to a more sustainable cosmetics. As Sahota states, the cosmetic industry is forced to consider alternative feedstocks for ingredients, leading to new green cosmetic ingredients emerging from agricultural-based raw materials. The cosmetic industry is a clear example of an attractive transition to the bio-based economy, and that is because many of the synthetic active ingredients featuring in skincare and beauty products can be substituted by green alternatives and easily extracted from plant-based sources. For instance, conventional petrochemical-based emollients can be substituted by sweet almond, coconut, or olive oils. Surfactants can be also obtained from coconut oil, or active ingredients that can be obtained from oats, avocado, or daisy flowers. And the same applies to all types of ingredients needed for cosmetics like emulsifiers, polymers, solvents, preservative, fragrances, and colors. More and more these bio-based ingredients are being proven to reach efficiency and quality standards with less environmental and health-associated problems. Several examples are now flooding the cosmetic market. Cosmetics made with active compounds from aloe vera, almonds, apricot, calendula, lavender, and many more. The results are cosmetic products with 100% natural origins and that are equal or even more efficient than traditional petrochemical products. Yet impressively promising, the bio-based cosmetics still have some flaws. And although plant-based sources are much more sustainable than the conventional cosmetics, the plant materials that are used as feedstock for ingredients still have to be produced. And when considered at large scales, agricultural production of these bio-based sources still has an impact on the environment. Huge extensions of lands have to be cultivated, with consequent depletion of our soils, large uses of water, deforestation, habitat degradation, and emissions. Indeed, although many modern cosmetics are advertised as natural and sustainable, high percentages of these products are based on exotic crops, most of which come from unethical sources, revealing the fact that natural not necessarily always means sustainable. But how could we then develop more sustainable cosmetics? To solve such an intricate problematic, the circular economy proposes the design of more efficient systems, transitioning from a linear way of production with huge amounts of feedstock and inputs and the generation of large volumes of residues, to more efficiently closed systems that requires less raw materials and optimizes the subproducts generated. The circular economy is an approach to a truly sustainable future with complete redesign of the way we consume. Such systems would provide society with quality products while at the same time take care of the natural and social resources. But how the cosmetic industry can become circular? Much progress has already been done in the development of sustainable and circular packaging for cosmetics. In contrast, just few innovations have been accomplished for circular cosmetic formulation products. Some examples start to show the possibility of creating efficient cosmetic formulations made from the byproducts and wastes of the agri-food industry. These organic byproducts are usually used for low-value purposes such as feed for livestock, compost, or for the production of bioenergy, where instead could be used for their health benefits in skincare and cosmetic products. Let's dive into a concrete example. The wine industry generates about 25% of waste respect the total volume of wine production, which means 1,000 tons annually for France, Italy, and Spain. The main waste generated is the grape pomace resulting from the winemaking processes, and it consists of grape stems, skins, and seeds. In this residue, we do not only lose biomass, but most importantly, we also lose many of the bioactive compounds of the grapes, like anthocyanins and polyphenols, which are highly valorized for their high antioxidant activity. Polyphenols like resveratrol have been associated with numerous health benefits, especially for their anti-cancer, anti-inflammatory, and antibacterial properties. Well, recent studies have calculated that around 70% of all polyphenols are lost in grape pomace and not collected in the wine. Sadly, most of this grape pomace residue is only used as organic matter feedstock for low-quality destinations or compost for the vineyard fields. Where these byproducts were traditionally considered a waste problem, now we are able to see the real high potential due to the richness on high added value compounds. Much research has been done in biorefinery approaches and extraction techniques to extract these biocompounds. This can be achieved through conventional methods like solid liquid extraction and ultrasound or microwave assisted extractions. However, non-conventional techniques are currently being developed to optimize extractions. Very innovative biorefinery approaches like pulsed electric fields, high voltage electric discharges, and supercritical fluid extractions. Each technique has its advantages and disadvantages, and the extraction efficiency really depends on what feedstock are we using. For instance, it's different if we only use the seed residue, the stems, or the entire grape pomace, and also depends on what biomolecule we are aiming to isolate. So for instance, by pulsed electric fields extraction, we can obtain threefold increased efficiency if we want to extract anthocyanins. On the other hand, if we want to obtain total polyphenols, high voltage electric discharge has been recorded to obtain sevenfold increased efficiency, respect conventional methods. And finally, with supercritical fluid extraction, a full 100% recovery can be achieved if you're looking to obtain only resveratrol extracts. Further research has been done by Dimo et al., where they even planned the technological and economical viability of the entire biorefinery for the extraction of added value products from wine byproducts. With grape skin, seeds, and wine lees as input, they are able to obtain antioxidant-rich extracts as the main product, but also other products like ethanol, yeast cells, and calcium tartrate. These products can be used as animal feed or chemicals, but the most valuable outcomes would be the antioxidant-rich extracts destined for food additives and cosmetics. How can then these antioxidant extracts be used then safely in cosmetics? Some research has also been testing the efficacy of these extracts on skincare products, and so far not only has it been shown to be safe, but it also has been proving to be very effective. In this in vitro study analyzing the use of grape pomace extracts for cosmetic products, we observed that extracts from grape pomace were safe and increased cytoprotection, therefore revealing that grape pomace can be a potential source of antioxidant raw materials for cosmetic purposes. Even more incredibly, results were obtained by researchers from the University in Sao Paulo found that antioxidant phenolic compounds obtained from grape pomace increased the sun protection factor of a sunscreen. Thanks to the synergistic behavior between the antioxidants extracted from the grape residues and the UV filters, the sunscreen was proven to be more effective at protecting the skin from solar stress damage. Similarly to the grape pomace scenario, many authors foresee a promising future for many other agri-food wastes and byproducts. Similar approaches are rising for materials like used coffee beans, citric peels, eggshells, rice residues, fish skins, and many others. All these organic resources that cannot be used as food anymore still hold many valuable biomolecules that can be revalorized for skincare uses. The future of sustainable cosmetics now relies on researchers, business innovators, and entrepreneurs to take the lead and offer society with honest, effective, and sustainable cosmetics.